Learning about every igneous rock, part 1, Adakites. So what are Adakites? Adakites are intermediate to felsic volcanic rocks. They have the geochemical characteristics that were initially thought to be of magma formed by partial melting of altered basalt subducted beneath volcanic arcs. What? So basically, most magma derived in a subduction zone comes from the mantle above the subducting plate when hydrous fluids are released from the minerals that break down in the metamorphosed basalt. They rise into the mantle, and then they initiate partial melting. So instead of the actual plate melting, water leaves the plate, goes up, causes melting here, and then that magma rises into the volcanic arc. However, DeFont and Drummond recognized that when young oceanic crust, which is less than 25 million years old, is subducted, Adakites are typically produced in the arc. They hypothesized that when young oceanic crust is subducted, it is warmer, meaning it's closer to the mid-ocean ridge where it was originated from, compared to crust that is usually subducted. The warming crust enables melting of the metamorphosed subducted basalt rather than the mantle above. Experimental work by several researchers has verified the geochemical characteristics of slab melt and the contention that melts can form from younger and therefore warmer crust in subduction zones. In this scenario, the subducting plate is actually melting and rising into the mantle and then rising up into the volcanic arcs. Drummond and DeFont also noted that Archean trahidamites, which make up most of the ancient crust of continents, have similar geochemical characteristics to Adakites. They suggested that the entire Archean crust may have been derived from partial melting of subducted oceanic crust during the Archean, because during early Earth, the temperature of the mantle was much hotter and more oceanic crust was generated and subducted younger. The proposal has been controversial and is still being argued among the scientific community. Make sure to follow for part 2 as we dive into the next igneous rock.